Okay, so one of the homework problems came up, and I'll just kind of summarize what we just talked about. One of the homework problems came up where you're supposed to do a surface integral. Of a curl of f dot d big S, or curl of f dot n dA, okay? I guess maybe I better do curl of f dot n dA, avoid confusion with of notation, okay? And you end up no matter how you try to parameterize this, you end up with a term of the form maybe it's a cosine of a sine of u or cosine of a cosine of u, okay? And you got to integrate that with respect to u, okay? But in the corresponding integral, and you can't do it, which means you cannot perform the surface integral. Okay, so this is impossible. To integrate by any standard integration technique, and probably by any technique other than Stokes' theorem. In the corresponding line integral, around the boundary, the offending term doesn't appear. In the integral is straightforward. And this is a typical application the Stokes theorem and divergence theorem. You have similar situations where one of the integrals is either impossible or you really just don't want to even think about it. Maybe it's possible. But if you look at the other integral, it's simple. In this case, your dot product that you get when you do the line integral turns out to be identically zero, so you don't even have to integrate anything. Okay? But there's no way that this integral could be done by standard technique. Now I suspect maybe if you look carefully at that integral, there might be a symmetry involved, where it's obvious that over, like if you go from 0 to pi, it's just equal and opposite to what you got from pi to 2 pi, or whatever, okay? So there might be a symmetry argument that allows you to do this. So I'll say this is impossible except maybe by symmetry. And the only reason I now mention that is because this integral is 0, and that often indicates that there's some sort of symmetry in the surface and the function. Like the surface in this case is a hemisphere, okay? Might be over the top of the hemisphere, you get equal and opposite expressions to what you have over the bottom of the hemisphere, and symmetry causes it to be 0. And I kind of suspect that's I don't know if it's probable or improbable, but I think there's a very significant chance of it. I would go with probable. I'd go 73 in that, just by intuition, which means it means nothing. Okay? Make sense? So you might look at it. I kind of recommend it as an exercise. Which exercise is that? Do you know what the number is?
393.
390.
6.7, 393.
393. So this exercise for reference is in the OpenStax Calculus 3. Again, 6.7.
6.7.
393?
Yes.
So it's worth,
Wait. I think it's 339. My bad. It just didn't look right when you wrote it up there.
339.
Yeah.
Okay? It's okay. Your memory's better than mine. Good.